Hi, I am Demján, and this is a video tutorial on some of the basic data operations when using the laser edit profiler. So in the previous video we already created a drawing, and now we need some way to save it. So let's begin by typing in the sample ID. It could be any string of characters. Okay, now the simplest possibility to save a drawing is to use this function, save as PDF or save as SVG. So PDF, I can just save it on the desktop. Looks like this. Should appear here soon, yeah. So it's a common PDF file where the drawing is saved, including the scale, etc. And an SVG file is a standardized vector graphics format, so I can save it as a SVG file as well. Okay, so this is the simplest way, but of course we want to have our data saved in some more structured way. So let's store it in the database. The store button does this, and we can access the database via the deposit tool. This opens the deposit database management software, which is connected with the laser edit profiler control application, and stores all the data. It's based on a graph database, so the database consists of nodes which are connected by edges, and here the nodes represent so-called classes. We can think of them as basically as, let's say, tables for our purposes, and those classes are, or the objects in those classes are connected by relations, which would be the edges of the graph. So by double-clicking the sample class, a table containing information on the already captured samples is shown. It has here the measured radius, the sample ID, info about orientation, whether the sample is properly oriented, some geometric data where the radius point, so where the radius was measured, and the sample reconstruction is in an SVG format. I can, if I want to store this file, get it out of the database, I can just drag it outside and it's stored, as you can see here, or I can just do copy and paste, it's saved. So it's every time in this SVG format. This is one way to get data out of the database. I can also just select multiple cells by holding Shift and clicking, and again copy and paste into, for example, into a spreadsheet application. So now the database is created, but it's still not saved. It's all the files are contained in a temporary directory. So what we want to do is to save the database. We have several options. The first would be save as file, so I can click save as file and point to a directory where I want the database to be saved. You see the format is JSON, which is a standardized human readable format to store data. I can just name it example. Click save. I'm asked whether to move all the resources to the new local folder currently from the temporary folder. So yes, I want that. We see now the local folder is shown here. The database identifier, which in this case is the path to the file, And if I open the folder here, you see the file that we just created is already there, and also there's a folder containing all the linked drawings, drawing reconstructions. So this is one way to save it. Another way would be to save it in a relational database or PostgreSQL database. So let's click it, save as database. Here we have to insert a connect string, which is a specific string saying that it's a Postgres database, the username, password, the host name or the IP address of the database, the port number, and the name of the database, and the identifier. In this case, it could be, for example, just LAP data with a hashtag. Is the name of the deposit database. So this database can contain multiple deposit databases specified by their identifiers. So I click OK, and it's saved in the Postgres database. The files, the drawing reconstructions, or any other, I can just link just any files as attachments to this database. They are all stored in this local folder. So similarly, it's with the relational database. The difference, so I can just save it, and the difference being that the data is stored in a not in a graph format, but in a or not in a proprietary format, but in a standardized relational database format. So there's lookup tables to create the edges between the nodes, which are the classes. The advantage is it's standardized. The disadvantage is that this is quite a data intensive way to store your data, so only recommended for maybe archival purposes. Okay, so now let's say I want to review my drawing. I can do this by I open the sample class. I can use the image view to look at the drawings. I can zoom them in, and let's say I want to correct one of the drawings. So I can again open the LAP control application, and I can just drag the image, drag and drop the image into the LAP application, and I can again work with it, adjust it, modify it, change the ID, and so on. Also, you notice that, for example, here I have a special attribute which says that I can specify whether the profile is oriented. I can also specify other custom attributes or descriptors. I can, when I click on data, edit descriptors, and a dialog comes up where I can specify how the different parts of the geometry of the drawing are stored in the database. And also I can specify additional custom descriptors by clicking add descriptor. Let's say I want to capture the material of the drawing of the pottery fragment. So material, let's make it a combo box, and the target class would be material, but it would be linked to from the sample. So the notation would be sample described by material, which has the descriptor name. Okay, now the field has appeared here, and I can say, let's say whether it's coarse or fine material. Okay, so fine and store. Let's have a look in the database. There should already be there should already be information about the material. If I double click an entry here, it opens the object view where all the details about the objects are and all the connected information. So here's the additional geometry, the handle and so on, inflection lines, and here I already see the material that has been associated with this drawing. So this concludes our tutorial. I hope it has been helpful to you, and have a nice day.